In our study of rational functions, we've learned that vertical asymptotes come from the zero of a non-removable factor in the denominator, and we express vertical asymptotes in equation form as x equals c. We've also learned that wholes come from the zero of a removable factor in the denominator, and wholes are expressed as an ordered pair. We can write that c f of c. However, the way that we locate horizontal asymptotes is a completely different procedure. To locate a horizontal asymptote, we're going to examine the relative degrees of the numerator and denominator. And remember, when we express the equation of a horizontal line, the form is y equal to a constant. Now, perhaps this cute little dog named Bobo Botten will help you to remember how to find the horizontal asymptote of a rational function. Remember that Bobo Botten eats dog chow. That's simply a mnemonic device for remembering the following three rules. Number one, if the degree of the denominator is bigger than the degree of the numerator, then the horizontal asymptote is y equals 0. So notice the degree of the denominator is bigger than the degree of the numerator. We can say it's bigger on bottom, then the equation of the horizontal asymptote is y equals 0. So Bobo stands for bigger on bottom, 0. Number two, if the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. So in this case, it's bigger on top. If it is bigger on top, then there is no horizontal asymptote. And then finally, number three, if the degrees of the numerator and denominator are equal, then the horizontal asymptote is y equals the ratio of leading coefficients. So if the degrees are equal, E stands for equal, then we're going to divide coefficients in order to get the equation of the horizontal asymptote. Now, this will probably make a lot more sense when we do an example. So let's take a look here at example 5. For the following rational functions, write the equation of the horizontal asymptote or state that no horizontal asymptote exists. So on example A, we have the function f of x. Notice the degree of the top is 3, and the degree of the bottom, if we were to multiply it out, would be 2. The highest powered term there would be degree 2. Notice when we multiply it out, we get x squared minus 3x minus 4. So we can see this case is bigger on top. That is, the degree of the numerator is bigger than the degree of the denominator. So there is no horizontal asymptote. So we'll make our conclusion, no, and I'm just going to abbreviate HA, no horizontal asymptote for that function. For example B, we have h of x, who, notice, has degree 2 on the top and degree 2 on the bottom. So we have equal degrees. So this is the eats dog chow case. So E stands for equal degrees. That's what we have right here. So when we write the equation of our horizontal asymptote, first of all, remember it's always in the form y equals. To figure out what y is equal to, we're going to divide coefficients, and in particular, we're talking about the leading coefficients. So I'm going to take the leading coefficient of the numerator, which is 1, and I'm going to divide it by the leading coefficient of the denominator, which is 2. So the equation of our horizontal asymptote here would be y equals 1/2. Let's take a quick peek at our calculator to understand how this horizontal asymptote fits into the graph. So what we want to do is type in our function at y equals. So we're going to type in the original given function, degree 2 on top, and degree 2 on bottom. Now I also want to program in the horizontal asymptote. So the original curve will graph in blue, the horizontal asymptote will graph in red, y equals 1/2. So let's take a look at how this works. So you have your original curve in blue and the horizontal asymptote in red. Notice how the blue curve levels out over that horizontal asymptote on the left side. It does cross it in the middle, which is sometimes the case with the horizontal asymptote, never the case with a vertical asymptote. And it levels out underneath that horizontal asymptote on the right. So you can see the horizontal asymptote, y equals 1/2, fits the curve. The last example here is g of x. The numerator is constant. We could think of it as 3 times x to the 0th power, because remember, anything to the 0th power is 1. So 3 times 1 gives us 3. But now we can see the degree of the numerator is 0. The degree of the denominator here is 2. So the degree of the bottom is bigger than the degree of the top. That is, it's bigger on bottom. Therefore, the equation of the asymptote is going to be y equals 0. Remember, BOBO stands for bigger on bottom 0. So the equation of our horizontal asymptote then would be y equals 0. Y equals 0 is the equation of the x-axis. So let's take a look at the graph and see how the asymptote fits the curve. So we have y equals, I'm going to type in a new fraction. We had 3 on the top, x squared minus 4x minus 10. I believe that was fun. Oh, minus 21. Let me fix that. Minus 21. And we want to type in y equals 0 for the equation of our horizontal asymptote. So the horizontal asymptote, again, limits the curve. You can see it leveling out here on the left side. The blue curve levels out over that horizontal asymptote, and on the far right side, it levels out as well. So remember, Bobo Botan eats dog chow as an easy technique for locating those horizontal asymptotes.